We have another way to solve systems. So we haven't looked at this elimination. We use substitution back on the exam 1 material. So now we're going to use elimination. Elimination is we're going to use when there's not an easy variable to solve for. I don't have any x's or y's by themselves like I did in these other two problems. So here's just another method that we can use here. All right, so the whole point is I want to get two of the numbers to be like opposites of each other. So I want them to be like maybe say 6 and -6. Or I could also do this one 12 and -12 because I want them to cancel out. And you'll kind of see where I'm going with this in just a second. So let's say I want my x's to be the same. So I want them to both be 6. And one of them, it doesn't matter which one, is going to be negative. So to get them to turn into 6, I've got to multiply by something. So let's just say I'm going to make the top one -6. So to get 3 to turn into -6, I'd multiply by 2. For the second one, to get 2 to turn into 6, I'm going to multiply by 3. And I'm going to do it to the entire equation. Notice I put the whole thing in parentheses. This only works if I do it to everything. So multiplying that top equation, I'm going to get -6 plus 8y is equal to -2. Multiplying the bottom equation, I'm going to get 6x plus 9y is equal to 36. My goal was to get one of the variables there to be inverses of each other, 6 and -6. The reason I do that is because 6 and -6 cancel each other out. 8y plus 9y is 17y, and -2 plus 36 is 34. So it makes a super easy equation for me to solve. I'm going to get y is 2. Then, just like we saw before, we're going to take that y and we're going to plug it in. Go to any of your original equations up here to do that. This one's going to take a little bit more steps than what we saw before, but it was less work up front, so it kind of works out in the end to be about the same amount of work. I'm solving for x. So my ordered pair, or where these two lines cross, is 3, 2. All right, I've got another one down here for you guys to try to solve. This one's kind of funky. I'm going to go ahead and tell you because it's really weird. We haven't seen one like it, but I told you we would. This one actually has no solution. So it's this case 2 right here where there's no solution. So I'm actually going to work it out as well since we haven't seen one like this. And in this case, we don't actually really need to multiply both equations. You could, but I can get 3 to turn into 6 without multiplying both equations. So just the top one is what I'm going to multiply by. I'm going to keep the bottom one exactly the same. And that's because my 6's are inverses of each other. So I already have an inverse right there. You don't always have to use 6. In this case, you might also see that the 4's are inverses of each other as well. So you don't have to use the number 6. Just an easy one for me to come up with examples for. So the x's cancel each other out and the y's cancel each other out. So I'm left with nothing on that left-hand side. When we're left with nothing, that's going to be that no solution. 0 doesn't equal 15. That makes no sense. $0 isn't the same thing as $15. So since that doesn't make any sense at all, we're going to have no solution.